Hey everybody, what's poppin'? Here for another video on distribution. And I know you're like, we've already done 2 videos on distribution, but we're going to do a third one, and we're going to look at distribution of powers, or exponents, over multiplication. Let's just jump right in and see what this means. Here's an example. We have simplify 3x inside parentheses to the second power. Now, if we were to approach this kind of following like a steps of operations sort of mindset, that 3x squared becomes 3x times 3x, right? And we can start simplifying this, and we can kind of get rid of the parentheses there, and we end up getting 9x squared, right? Notice that we had a 3 times 3, and that's why we got the 9, and the x times x becomes x squared, okay? Notice we end up with 2 3's being multiplied and 2 x's, right? So from a distribution standpoint, what this kind of looks like, let me get my arrow in there too, is that we have this second power, and the second power effectively gets distributed inside the parentheses to both of those parts, right? So we end up with a 3 squared and an x squared, just like we had over here, and we're done. That's what distribution of powers or exponents across multiplication means, right? Now let's look a little bit at the structure of this, make sure we know what's going on. Here we have our 3x squared, and if you notice, inside we have a single term, right? We have one term, but that one term is made up of 2 factors. Now what's a factor? If only there was a place we could look to find all of the language that we need. Oh wait, we have the word wall in your classroom. So we pop over to the word wall in the classroom and we see this, right? A factor is a number or quantity that when multiplied with another produces a given number or expression, okay? So for one example, in 7xy, right, 7x and y are all separate factors. And if you wanted to write 15 using its factors, you would write it as 5 times 3, right? So the idea is that factors is all about things being multiplied together, okay? So we're distributing this second power to both of the factors. And this is kind of like when we would distribute with multiplication across addition, right? In this case, there was one expression, and that one expression had 2 terms. And this 2 gets distributed to both of those values there, right? So in many ways, it is just like distributing multiplication, but it's with powers across multiplication rather than multiplication across addition. So let's look at an example like this. 2xy to the 5th power. Now, some people, when they distribute this, they end up kind of framing it like this. Oh, look, see, I have an x and a y here. There's my variables, and I need to make sure both those things go to the 5th power, right? And you end up with this, 2x to the 5th, y to the 5th, and this is wrong. There's an error there. What this person did was they forgot about this 2 value here, right? Because look, how many terms are there in this, how many factors are there in this term? There are 3, 2, x, and y. So all 3 of them need to be distributed to, right? So the 5 goes to the 2, the x, and the y. All of them get raised to the 5th power, and we end up with 2 to the 5th, x to the 5th, y to the 5th. Now another thing to be careful about, we're not done yet. X to the 5th can't be simplified anymore. Y to the 5th can't be simplified anymore, but 2 to the 5th can. 2 to the 5th is 2 times 2 times 2 times 2 times 2. That's 32. So we should end up with 32 x to the 5th, y to the 5th, okay? That's kind of our final simplified version of this, okay? So again, main thing, look at the number of factors and make sure each factor gets that exponent when you're distributing, okay? Now, when do we distribute? Here's 2 examples, right? We have 4 times x to the 3rd, and we have 4 times x to the 3rd. But let's look at this really carefully, right? In this case, we only have this one value inside the parentheses, right? And so from like a steps of operation standpoint, right, this exponent is going to happen before this multiplication on the outside happens. So this one ends up as just 4x cubed, right? The 4 is not being raised to the third power, just the x. Whereas in this case over here, right, the multiplication that's there inside of those parentheses, right, is inside the parentheses. So that's kind of what's happening first. It's being grouped together. And both of these values, both of these parts or these factors would get raised to the third power, resulting in 64x cubed. So these two things look similar, and we say them really similarly, 4x cubed. But we have to be super careful about thinking about parentheses and stuff like that. Okay? And that's a boosh. I'm out. Peace.